Hello and welcome to Edisati. Let's discuss the part 2 of geometry, and in part 2 we'll be talking about triangles. Now, a triangle, any three lines in a plane of which no two are parallel, either concurrent, forms a triangle. So, a triangle is formed with three lines in a plane. It has three sides and three interior angles. There are certain properties of triangle that you always need to keep in your mind while doing questions. The first one being the sum of all the interior angles of a triangle add up to 180 degree. So if you look at it, it is angle A, B and C. The sum of angle A plus B plus C should be equal to 180 degrees. The next one being the exterior angle of a triangle is equal to the sum of opposite interior angles. So if I talk about exterior angle C, this is exterior angle C, this will be equal to opposite interior angles. So if I talk about this here, there are three exterior angles that I have. So exterior angle A will be equal to this. Exterior angle A will be equal to angle B plus angle C, interior angle. Exterior angle B will be equal to interior angles A and C, and exterior angle C will be equal to interior angle A and B. The third thing being angle of a triangle is directly proportional to the side opposite to it. So the greater the angle, the larger will be the side opposite to it. The smaller the angle, the smaller will be the side opposite to it. So as the angle increases, the side opposite to it also increases. Therefore, we use this nomenclature. Small a representing the side length will be exactly opposite to capital A. Small b will be the side length opposite to capital B. Small c would be the side length opposite to angle C. So, side and opposite angle are directly proportional to each other. Let's look at a question. In the figure given below, which of the following must be true? So, I have two angles which are given to me. So, if you look at it, this will be B, this will be angle A, this will be angle C. So, the two angles which are given to me as 80 and 60. I know the sum of all the angles, if I add x, it should be equal to 180. So that means x should turn out to be 40 degrees. This should be a 40 degree. Now I know the greater the angle, the larger will be the side opposite to it. Since out of all these three, A angle is the greater, so that means A side will be the greatest one. Now the second comes C angle. So that means C side will be smaller than A but greater than B. Since the angle opposite to side length B is the smallest one, so that means the side length B will be the smallest side that I have, so giving me D option as my answer. Continuing with the properties, the next property is each side of a triangle is greater than the difference and less than the sum of other two sides. This is very important property that we have, and I can write it like this. So if I talk about the side length A has to be less than the sum of the other two sides but greater than the difference of the other two sides. The sum of two sides is always greater than the third, and the difference of two sides is always lesser than the third. So I have to keep in mind both the conditions whenever I am talking about a triangle. For a triangle to exist, both the conditions should satisfy simultaneously. The sum of two sides should be less and the difference of the same two sides should be greater than the third side. Now, for example, the sides of the triangle could not have the lengths 4, 7 and 12. Because if you look at it, if I add up 12, if I add up 4 and 7, what do I get? 11. The sum of two sides should always be greater than the third. Now having a third side 12 means this triangle does not exist. I cannot have these three sides as the sides of a triangle. The perimeter of a triangle is the sum of all the sides. So if you add up A, B and C, which is sum of all the sides, what you end up with is known as the perimeter of the triangle. Area of the triangle is given by the formula half into base into perpendicular height. So if I just refer to the figure on the right, it will be half into the base that I am taking into the perpendicular height. The perpendicular height is always from the opposite vertex. Now, I have been given three sides for the triangle. Any of the three sides could be taken as the base. If I have taken AC as the base, I could take AB as the base, but for AB as the base, the length of the perpendicular has to be drawn from the opposite vertex. Moving ahead, let's look at a question that we have. If the length of two sides of a triangle are 5 and 9 respectively, then which of the following could be the length of the third side of the triangle? So I have to look at what are the possible options for the third side of the triangle, and I have to indicate all such lengths. So if I look here, I know that the sum of two sides, which is coming out to be 14, has to be greater than the third. So that means the third side could be 13, could be 12, could be 11, could be 10, could be 9, but it cannot be greater than 13. And the difference of the two sides, which is 4, should be lesser than the third. So that means the third side should start from 5 and end up with 13. These are all the possibilities that I have for the third side. 3 cannot be my answer, 5 can be my answer, 8 can be my answer, 15 and 17 cannot be my answer. So the two options that are my answers would be 5 and 8. These are the options that are possible with the given side as 5 and 9. Again, continuing with the properties, we will be looking at a special case of a triangle, which is an isosceles triangle. A triangle with at least two sides equal, or I should say a triangle with at least two congruent sides is known as an isosceles triangle. If the triangle has two sides which are equal, then the angles opposite to equal sides would also become equal. So the corresponding opposite angles are also equal, or they are also congruent. The converse of it is also true. If two angles are equal, the sides opposite to equal angles are also equal. Now this is the figure that you need to look at when you are talking about isosceles triangle. Two sides are equal. So the length of AB and the length of BC turns out to be equal. This is a symbol that I use when I am representing equal. So angle opposite to these sides would also be equal to each other. The third side is not equal to A, it will be anything else. So if I look here, this is what an isosceles triangles look like. And the perimeter of such a triangle, which is the sum of all the sides, would be given by 2a plus b. Or I can write a plus b, which ends up giving me an answer of 2a plus b. And area would be half into base that I have into height. It will be the same formula that I will be using for area. Now to find out the height, I can use the concept that when two sides are equal, the perpendicular from the opposite vertex would divide the base into two equal parts. So AD, the length of AD will also be equal to the length of DC. Therefore, I can apply the Pythagoras theorem in this triangle and I can get A square is equal to h square plus b square by 4. So I can find the value of the unknown h using the Pythagoras theorem, and this Pythagoras theorem has been used here by taking unequal side as the base. Moving further, we'll be talking about equilateral triangle. A triangle with all three sides congruent is known as equilateral triangle. Therefore, the measure of each of the three interior angles for such a triangle is also equal and comes out to be equal to 60 degrees. This measure would be fixed. Now the perimeter in such a case would be equal to 3a because all the three sides are equal. So adding up a plus a would give me an answer of 3. And the area of such a triangle is given by root 3 by 4 a square. A is the length of each side and multiplying it with 3 by 4 would give you the area for an equilateral triangle. The height of an equilateral triangle is given as root 3 by 2a. I'll just, this typo error that has been there. So h is equal to root 3 by 2a and area is equal to root 3 by 4a square. These are the two things that you need to keep in mind whenever you get a question on equilateral triangle. Let's look at a question. An equilateral triangle ABC has a height AD equal to 6 root 3. What is the area? Now I know the height of an equilateral triangle is given by root 3 by 2 into side, and that is equal to 6 root 3. So just cancelling this thing out, that means the side of an equilateral triangle is 12. The area of an equilateral triangle would be given by root 3 by 4 side square. So root 3 by 4 into 12 into 12. Now I'm not doing that thing because I know anyways it will be cancelled out. So 12 into 3, 36. Root 3 would be my answer for this question. Moving further, we'll talk about right angle triangle. A triangle with an interior angle equal to 90 degree is known as a right angle triangle. So one of the interior angle is 90 and the side opposite to this 90 degree angle is known as hypotenuse. So this side is known as hypotenuse. It's angle ABC, and since this angle is 90, the sum of other two angles A and C would also be equal to 90 degree. So A and C add up to give you 90 degree. So if I look here, 90 degree. So that means B side has to be the greatest side. Hypotenuse is the longest side in a triangle. I can apply Pythagoras theorem in a right angle triangle. The theorem says the length of the hypotenuse square would be equal to the sum of squares of base and perpendicular. So one side will be taken as base, another side will be taken as perpendicular. So base square plus perpendicular square is equal to hypotenuse square. The other two sides, base and perpendicular, are also known as legs. So I can use the word base or perpendicular, or I can use the word legs. The perimeter of such a triangle is given by A plus B plus C because all the three sides are not equal to each other. The area of a right angle triangle would be given by half into base into perpendicular. So it will be half base into height. One side will act as a base, the other side will act as a height because base and perpendicular are anyways at 90 degrees to each other. Now we'll talk about a special case of a right angle triangle. Isosceles triangle. Isosceles mean the other two angles which we talked about, this was a 90 degree, the other two angles also turn out to be equal. So this is 45, this is 45. If two angles are equal, the side opposite to equal angles are also equal. So applying Pythagoras thing, I would get the length of hypotenuse as a root 2 because it is a square plus a square whole. So I'll get my answer as a root 2 as the length of hypotenuse. So if I just look here, the length of the hypotenuse is a root 2 that I get. And perimeter for such a triangle would be given by sum of all the sides. So it will be a plus a, which is 2a plus a root 2. So it is a plus a root 2. That will be the perimeter of this kind of triangle. However, the area of triangle would be equal to half into a square because base is equal to perpendicular and both are equal to the value which is a. So half base into height, which is half a square, will be the area for isosceles right angle triangle. The other that you have is a special right angle triangle which is a 30, 60, 90. One is 90, the other two angles sum up to give you 90 but they are not equal. They are actually equal to 60. One of the angles is equal to 60, the other angle is equal to 30. Since it is the largest angle, so the side opposite to it has to be the largest side. The other two sides are given by a and root 3a. So this is the thing that you need to remember. This will be a, root 3a and 2a. This will be for 30 degrees, this will be for 60 degrees, this will be for 90. So if this is the angle, the side opposite to this angle would be given by a, root 3a and 2a. So these are the sides. The perimeter of such a triangle would be given by a plus 2a, which is 3a plus a root 3. And the area would be given by half into base. Now the base here is given by root 3a and the height is a. So it will be root 3 by 2a square. That will be the area for special right angle triangle. Let's look at a question that we have. In a triangle below, if BC is equal to 4 root 2. So BC, this length BC is given to me as 4 root 2. Then AB is. This is what I have to find out. Now if I look at it, one of the angle is 105 degree, the other one is 30 degree. So that means it anyways is giving me 135. The other angle has to be 45 for it to sum up to be equal to 180 degree. So this angle is 45 that I have. Now, I have to find the length of AB here. I know that the length of AB would be greater than 4 root 2. So 4 into 1.414 root 2 is approximately 1.414. I can approximate it as 1.5. So if I just look at it, 4 into 1.5 would be equal to 6. So if I just look at it, this side, which is AB has to be greater than 6. Has to be greater than 6 because the angle opposite to AB is greater than 30. So if I just look at the answer options and I scan through them, 4 root 3 is greater than 6, 8 is greater than 6, 4 root 6 is greater than 6 and 10 is greater than 6. So in such a condition that I have, I can apply the sine formula. Now what is the sine formula? I know that that this side will be proportional to an angle. If I have to bring an equality sign, I will write it equal to sine of the angle opposite to it. So if I just use this thing, A over sine A is equal to B over sine B is equal to C over sine C. So I'll be using this formula. This is the formula that we'll be using to get the relationship between angle and the opposite side. So if I just use here, I need to find AB and sine of the angle, it will be sine of 45 degree. And this will be, I know this length 4 root 2 and it will be sine of 30. So you need to know what is the value for sine 45 and sine 30. Sine 45 is 1 by root 2. So I'll just write down 1 by root 2 and this is 4 root 2 and sine 30 is 1 by 2. So I just need to do the calculation part and I'll get my answer for AB as 4 root 2 into 1 by root 2 into 2, giving me an answer for 8. So my answer comes out to be 8. Let's look at another question. What is the area of the quadrilateral EFGH given below? Now for this kind of questions, I would try to split it up into two triangles. Now quadrilateral is always composed of triangles. I'll try to join FH and get it into two triangles. Now this is a right angle triangle, 6 and 8. Now I can use the formula 6 square plus 8 square whole square root will give me the value of FH using the Pythagoras thing. 36 square plus 64 square, which is 100, square root of which it is 10. So I get one right angle triangle and one equilateral triangle with each side measuring 10. If I just add up both the answers, I'll get my answer. So I'll use the formula which is half base into height for a right angle triangle plus root 3 by 4 into side square for an equilateral triangle, and I'll add it up. So if I just look at the thing, this will be 24 plus 25 root 3, giving me option number 1 as my answer. So this is the correct answer that I have. Let's look at another example. A 10 feet ladder leans against a vertical wall and forms a 60-degree angle with the floor. So it's something like this. So this is the floor and this is the angle that it forms is 60 degree. Assume the ground below the ladder is perfectly horizontal. How far above the ground is the top of the ladder? So this is something that I need to form. And it's a 10 feet ladder. So this is 10 feet which is anyways given to me. This is 60 This is 90. This has to be 30. So I know if it's a special case of a right angle triangle, the sides were A, 2A and root 3, A root 3. So I just need to find out the value of A. If this is 2A is 10, A is 5. It's a very simple question that we have. Moving forward, we'll understand the concept of congruency and similarity. Congruency. If two triangles have the same shape and size, they are known as congruent triangles. More precisely, the two triangles are congruent if their vertices can be matched up so that the corresponding angles and the corresponding sides become equal. The following three propositions can be used to determine whether the two triangles are congruent by comparing sum of their sides and sum of their angles. So the first one being triple S. All the sides for both the triangles are equal. The two triangles would be congruent. SAS, two sides are equal and the corresponding angle between the two sides is also equal. The third one being AAS, two angles are equal and the third side is equal. Fourth one being RHS, in case of a right angle triangle there has to be a right angle in both the triangles and other two sides are equal. So basically if you have two triangles of same shape and size, they can overlap one another and their corresponding vertices will match each other. Those kind of triangles are known as congruent triangles, and these rules can be used to prove that the given triangles are congruent triangles. Similarity. The two triangles should have the same shape but not the size. So shape has to be same but not the size. Shape is determined by angles. So that means if all the angles of first triangle are equal to the corresponding angles of another triangle, the two triangles would be similar, but they need not be equal in size. More precisely, I can say two triangles are similar if the vertices can be matched up so that the corresponding angles are congruent or equivalent. The lengths of the corresponding sides need not be equal, but they should have the same ratio, also called as the scale factor of similarity. So if I just look here, the ratio of the corresponding sides for a similar triangle has to be equal. Now it is not necessary that I need to prove that all the angles are equal. Two angles would also suffice, because if two angles are equal, the third one automatically becomes equal. So here if I say angle A is equal to angle D, angle B is equal to angle E, therefore angle C would automatically become equal to angle F. So I have, whenever you have a situation of this type, the ratio of the corresponding sides becomes equal. So if I say if triangle ABC is similar to triangle DEF, the ratio of the corresponding side means ratio of the sides opposite to equal angles. So I'll have to look at equal angles. I'll look at the ratio of the side opposite to equal angles. If A and D are equal, I'll talk about BC and EF, that ratio. If B and E are equal, I'll talk about AC over DF. AC over DF. And the other one, this ratio is equal. And it is very, very important to take into consideration the order here, because if you go wrong with the order, your ratio would not be the correct one that you note. Now in case of similarity, if the sides are in the ratio A is to B, their heights will also be in the ratio A is to B. Their perimeters will also be in the ratio A over A is to B, but their areas will be in the ratio A over B whole square. Square of the scale factor, or I will write it as A square over B square. If the triangles are congruent, they will have the same height, they'll have same perimeter, they'll have same area, they'll have exactly everything the same. But for a similar triangle, their heights are in the ratio A is to B, their perimeters are in the ratio A is to B, and their areas are in the ratio A over B whole square. Let's look at an example. In the figure below, AC is equal to CE is equal to A. So AC is equal to CE is equal to A. That means it's what? It is a equilateral triangle which is given to us. If B and D are the midpoints of AC and CE, so that means this is 4, this is 4, this is 4 and this is 4. What is the area of the quadrilateral ABDE? ABDE. I need to find out the area. Now look at it. Area of the quadrilateral can be find out area of bigger triangle ACE minus area of smaller triangle BCE. Now if I look here, if I look at triangle ACE and triangle ACE and BCE, if I look here, angle C is common that I have. Angle C is common that I have. So it will be here also and it will be here also. The second thing that I need to understand is the basic proportionality theorem that I have studied before. So basic proportionality theorem says if two lines are parallel, then the ratio of, if three or more lines are parallel, then the ratio of the transversals would become equal. So this is 4 over 4 is to 4 over 4. That means BD would be parallel to AC. If BD is parallel to AC, that means the corresponding angles would also be equal. And therefore, the triangles would become similar. Once the triangles are similar, the sides are proportional. So if I look at a smaller, this side is 4 in comparison to 8. That means half. 4 in comparison to 8. This side should also be 4 in comparison to 8. So the length of BD comes out to be 4. So if I look at both of them are equilateral triangles, this will be root 3 by 4, 8 square minus root 3 by 4, 4 square. So I can take root 3 by 4 common. It will be 8 square minus 4 square. I can do a square minus b square as a plus b into a minus b. So I'll get 12 root 3 as my answer for the area of quadrilateral ABDE. Let's look at another example. In the figure below, if BE and AD intersect at point C. Whenever this thing happens, two lines intersect, vertically opposite angles are equal. So if I look at this and this triangle, these two angles are equal, and it is given that this angle is also 40 and this is 40. So if two angles of a triangle are equal to the other two, the third bounds to be equal. So that means I can say triangle ABC is similar to. Now A is similar to D. I'll just name it like this. B is equal to E. So it will be DEC. ABC is similar to DEC. Then the length of BC is what you need to find out. BC, this is, let me call it as X. Now whenever the two triangles are similar, their sides are proportional. Sides, I'll write it corresponding to opposite angles. A and D. The side opposite to A is X. The side opposite to D is 15 is equal to B and E. B, the side opposite to B is AC. The side opposite to E is DC. This is not required to mean the question. And C, the angle, the side opposite to angle C here is 6 and it is 10 here. So I can just eliminate this. I can just combine the first and the first and the third, and I can get my answer for the value of X. X will be equal to 15 into 6 by 10. So 2 and 3, 3 and 3, my answer is 9. So the value for BC is 9. Let's look at another example for triangle similarity. These are the two triangles which are given to you. You have to find the length of the hypotenuse K. Now if you look here, if you look at this triangle and this triangle, I'll just name them A, B, C, you want to name it anyways, D and E. Now if you look at it, angle B will be equal to angle D because both are equal to 90 degrees. Now, in order to find this thing out, I need to prove that these two triangles are similar. However, I can use a Pythagoras here. 13 square is equal to 12 square plus x square. X, if I solve it out, it comes out equal to 5. So I know 5 square plus 12 square is equal to 13 square. So that means this side is 12.2 minus 5, so which is coming out to be 7.2. But since I don't know the length of this side, I cannot find out the side K. So I need to prove that the two triangles are similar. It's very difficult for me to look at the angles in this case because it is not evident. I look at this, I prove this angle as theta. What will be this angle? The sum of these two angles would be what? 90 minus theta. Or I can say that the exterior angle will be equal to 90 plus theta. Exterior angle is equal to sum of opposite interior angles. So 90 plus theta is this. This is anyways 90, so that means this is what? Theta. If this is 90, this is theta. This has to be 90 minus theta. So this theta and this theta are equal. And the other angle 90 minus theta is equal to 90 minus theta. So I'll say angle A is equal to angle C, which is equal to theta, and angle I would write it C is equal to angle E, which is equal to 90 minus theta. Now I can apply the similarity rule for corresponding sides and get my answer. So if I look at here, the angle the side opposite to theta in this triangle is 5 and here it is 80. The angle opposite to 90 degree here is 13 and there is K. The angle opposite to 90 minus theta here is 12 and there is 7.2. So I can just write 7.2. So I can just look at this thing. So I can get the value of K. K will be equal to, if I just solve it out for K, it will be 13 over 12 into 7.2. So just solve this thing out. In case you have a calculator available with you in the exam, it will be very simple calculation that you will be doing. So 13 into 7.2 gives you 93.6. Divide it with 12, you will get your answer as 7.8. This is the value for K that we have in here. Thank you so much for watching the video. I hope you have understood the concept of triangle. Please like us and subscribe us on our YouTube channel to get more updates. Like us and follow us on Facebook and Twitter to get exam related updates. Thank you so much. Have a nice day.